Hey guys, I wanted to go over how to do the IXL assignment level M Y7. So go ahead and get out your notes, the ones that we did earlier today. These ones here, the unit circle, and that's what you'll use to follow along. So let's take a look at this first problem. First it says the sine of 60. Okay, the sine of 60. Well, first we have to remember, considering SOHCAHTOA, that sine of 60, or sine of anything, let's say sine of some angle, theta, is equal to the opposite side over the hypotenuse. Okay, so what we're going to do is we're going to look for 60 degrees. And on our triangle, on our unit circle, 60 degrees is here at this point. And we know that by using our 60-degree triangle. And I know that the sine of this 60-degree angle is going to be the opposite side over the hypotenuse. Okay? And we already filled in our coordinates. And the opposite side here is our y value. And the y value here is square root of 3 over 2. And the hypotenuse is going to be 1. We know that anything over 1 is the same number, or the same value, so that simplifies to square root of 3 over 2. So there's our answer for the first one. So we go ahead, go here, type in square root of 3 over 2. Click submit, and there we go. Okay, so now the next one, cosine of 30. Well, cosine says that we're going to take the adjacent over the hypotenuse. Adjacent over hypotenuse. Okay, so again, we're looking at 30 degrees. So that means I'm going to need to bring up my 30-degree triangle. 30 degrees is right here. And adjacent side, the adjacent side is the x value, which is the square root of 3 over 2. And over the hypotenuse, so that's this side here, and that's 1. And again, it's just the same value over 1, square root of 3 over 2. So square root 3, and then over 2. Okay? Now how about if we have a 45-degree angle? Okay, well let's get over a 45-degree triangle. Okay, our 45-degree angle is right here at this point. And the sine, again, let's flip this page. The sine is going to be the opposite over the hypotenuse. So sine of 45 is going to be the opposite over hypotenuse. So the opposite of 45 is the y value, and the y value here is square root of 2 over 2. And the hypotenuse, again, is 1. And so it remains the same value as rad 2 over 2, because it's just over 1. So there's our sine of 45 degrees, rad 2 over 2. Okay, so now how about if we have radians? Then what do we do? Well, go back to our notes. Remember, radians is the same thing as degrees. It's just a different way to measure. So, in other words, we really just have to consider this pi over 3 like it's an angle. But we have to figure out what angle is that on our chart. Well, let's go back to our chart and figure out what the radians are. Okay, well I know here that at 0 degrees, at this point, that it's 0 pi. And you know if I go all the way across to the other side, that's 180 degrees. And half a turn in the circle is pi. And if I go up here, 90 degrees is halfway between 0 and 180. So that means it's going to be half of pi, or pi over 2. And that's pi over 2 written kind of sideways. So then what about the rest of my values? Okay, well, how about here? Right here in the middle. Okay, well this is 45 degrees. I know that. 45 degrees. And it's going to be half of 1/2 pi, or pi over 2. Well, half of that is pi over 4. Okay? And then what about here? Well, I'm not really sure, but I know that that's 30 degrees. And I want to convert from 30 degrees to radians. And if you remember from last week, we converted degrees to radians and radians to degrees. And I want to know what 30 degrees is in radians. Well, what I do is I multiply times pi over 180. So to find this 30 degrees, 30 times pi over 180. Well, that's going to be, let's see, it's going to be 30 over 180. We can reduce that, and that will be 1 over 6 pi, or which is also the same as pi over 6. Okay, so then this is pi over 6. Okay, so then what about this last one, the 60 degrees? Okay, well, let's convert that. Same thing, 60 times pi over 180. Okay, so let's reduce that, divide both of them by 60. That'll be 1 over 3 times pi, which is also pi over 3. Well, there it is, pi over 3. That's what we were looking for. What is pi over 3? It's the 60 degrees. So again, I'm going to write that on my unit circle, that this is pi over 3. And I'll use that for reference as I do these problems. And we can fill in the rest later. All you have to do is convert the rest of them, and I'll show you what they all are at the end of the video. Okay, so now I know that pi over 3 is the 60 degree mark, so I'll use my 60 degree triangle. And cosine is adjacent, so the x value here, cosine is adjacent, and the x value there is going to be, oh, looks like I made a mistake there. That is not square root of 2 over 2. That should be 1 over 2, 1/2. Okay, so the x value there is, so cosine of pi over 3, or 60, is going to be 1/2, our x value, over the hypotenuse, which is 1. So our value is 1/2. Cosine of pi over 3 is 1/2, 1 over 2. There we go. And one thing I want to point out is that if you notice, I haven't really been using quadrant 2, quadrant 3, or quadrant 4 of the unit circle. I really only need to use this for now, just because the values we're dealing with are between 0 and 90 degrees. But this value here could be greater than 90 degrees, in which case I would need to know what all these are. And I'll fill those in later, so you guys can see those and fill them in on your own circle. Okay, so this next one is tangent of pi over 6. Tangent of pi over 6. Well, again, let's go to our circle here. What is pi over 6? Pi over 6 is 30 degrees. Okay, so that means I'm in my 30 degree triangle. Okay, and tangent is going to be the opposite side over the adjacent side. Now the opposite is going to be our y value, which is 1/2. So 1/2 on the top. And the adjacent side is going to be our x value here, this side, which is square root of 3 over 2. And let's go ahead and set that up in a different way by separating them and putting them between the division symbol. 1/2 divided by square root of 3 over 2. And let's flip the second fraction and change the sign to multiplication. And those 2's cancel out. I get 1 over 3 1 over rad 3. Let me zoom in so you guys can see this. 1 over rad 3. And then, of course, we don't want a radical in our denominator. So we multiply both top and bottom by rad 3. And 1 times rad 3 is just rad 3 itself. And then rad 3 times rad 3 cancels out the radical. So we have radical 3 over 3. And that is the tangent of pi over 6 over 3. Hopefully I got it right. Yes, I did. Okay. Well, that is how you guys do that. If you have any more questions, you can come see me in class, or we'll go over this tomorrow in class. Okay, the last thing I wanted to do for you guys, I forgot to mention, is that I completed the rest of the circle here, so you can pause the video and fill in the rest of the degrees and radians. So you just have that there as reference. Another thing I wanted to point out is that if you notice, as I was doing all those different problems, let's say this one, let's say I was doing cosine, right? Well, cosine is the adjacent side over the hypotenuse. And the adjacent side is always the x value. It's always the x value. So in other words, cosine is always going to be the x value. And sine is always opposite over hypotenuse. So sine will always be the y value. So that's another quick way you can reference this, is saying, oh, well, if it's cosine of 30, well, I know then that is the adjacent side, which is our x value, pi 3 over 2. If it's sine of 30, then that's the opposite side, which is the y value, which is 1 over 2.